Everyone. So today we'll do these exercises. So these involve the definition of the derivative, the limit definition, and of course we won't be allowed to use any rules that we have seen in class. Okay, so let's get started. First of all, let's give ourselves a small refresher or a reminder on what a differentiable function is. So we say that f is a differentiable at a number a if the limit as h approaches 0 of f of a plus h minus f of a over h exists, or that if f or when we write that f prime of a is the limit as h approaches 0 of f of a plus h minus f of a over h. One can also notice, as we have seen in class, that f prime of a is the same as the limit as x goes to a of f of x minus f of a over x minus a, this average rate of change thing. Okay, great. Now, just in order to define or to be able to be differentiable at a, f needs to be differentiable on an open interval, f needs to be defined, sorry, on an open interval containing a. And then if we consider all the possible values of x for which the limit of f of x plus h minus f of x over h exists as h approaches 0, we can obtain a function that assigns to a number x the number f prime of x. This is called the derivative function of f. Okay, so these are the two limits that we're going to have to study. Of course, a can be replaced by anything else, like t, for example, or x, provided, we don't, f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a over h. F prime of x is also the limit as h goes to 0 of f of x plus h minus f of x over h. So these are the two most important definitions of the limit. These are equivalent definitions, I guess. And now let's move on to exercises. So we'll use the definition to find, oops, what happened here? Okay, so we'll be using a definition to find the derivative of this function. This is a polynomial function, of course. Let's try and do this using the definition. Okay, so first of all, f is defined on R. Really, let's do this here. Well, f is defined on R because f is a polynomial, right? So it's defined everywhere. So my infinity here is messed up. Okay, great. Now, in order to find f prime of x, I mean, we know what the answer is, right? This is a good way to check our answers using the derivative rules. The derivative rules are a good way to check our answers. So we'll have to look at the limit as f of x plus h minus f of x over h as h goes to 0. I mean, let me write down what, well, so far we can see what f of x is. So what is f of x plus h? It's 2x plus h cubed plus 3x plus h squared plus 2 minus 2x cubed plus 3x squared plus 2 over h. This is the limit as h goes to 0. Now it's a better idea to regroup terms together, squares together and cubes together. And notice that the 2 will cancel out, right? You have a 2 here that will cancel with a 2 here. So let's write this. And at the same time, well, I mean, let's keep things a bit slow. So 3x plus h squared minus 3x squared, and the 2 will cancel out. I mean, let's just write them here. It's not a big deal. Over h. Great. Now, what do? I'll just factor out a 2 and get x plus h cubed minus x cubed plus 3x x plus h squared minus x squared plus 0 over h. Here, of course, there are many ways we can proceed. This is the limit as h goes to 0. You can factor this, as a difference of two cubes, or you can expand that. That's not a problem. Either way works. So this is a cubed, x cubed plus h cubed plus 3 x squared h plus 3 h squared x minus x cubed. Here also you can factor it as a difference of 2 squared or 2 squares, or expand the first squared. So it's x squared plus h squared plus 2xh minus x squared over h. And here I'll allow myself to go a bit fast. Well, I mean, let's actually do it. This is just h cubed plus 3x squared h plus 3h squared x plus 3h squared plus 2xh, and that's it, over h. Now notice, what do you get here? You can factor an h out, right? All you need to do is factor an h out. It's limit as h goes to 0. Let's factor an h from here. So what do we get? We get h squared plus 3x squared plus 3hx plus 3. Factor an h out here as well. H plus 2x. Awesome. Over h. Now, I mean, you can do it quickly if you wish, or you can take your time, which may be a better idea if you're not comfortable with the algebra. But the idea is to refactor an h out. Okay, so let's factor an h out and put the 2 in. So it's h, 2h squared plus 6x squared plus 6hx, right? I just put the 2 inside. And then I factored the h out and I put the 3 inside. It's 3h plus 6x. Okay, and I put a big bracket here. Very good. I can cancel the h out. And I get it's the limit of 2h squared plus 6 x squared plus 6hx plus 3h plus 6x. And what is that? So everything that contains an h goes to 0. So we're left with 6x squared plus 6x. So if f of x is equal to x cubed plus 3x squared plus 2, then f prime of x is equal to 6x squared plus 6x for all x and r, right? Because here the limit exists for any real number x. Okay, and that you can check with the limit laws. Whenever you have an exercise involving the definition of the derivative, it's better to verify your answer with the limit law, with the derivative laws. Okay, here it's obvious the derivative using the polynomial of a polynomial, we know how to do that. Okay, great. Awesome. Very good. Let us now move to a slightly harder example. F of x over x plus 3 divided by 5x plus 2. So for example, the domain of f, first of all, is defined, f is defined for all x different than minus 2 over 5. This is clear. Okay, now let us look at the derivative of f to assess when this derivative exists. So the limit as h goes to 0 of, let's see, of f of x plus h minus f of x over h. Of course, x is different than minus 2 over 5, so that f of x exists. Okay, great. Now here it's a bit, the algebra will get a bit, will get a bit complicated. We have a lot of fractions, but we should be comfortable doing these sorts of calculation. So f of x plus h is this. minus x plus 3 over 5x plus 2 over h. Great. Now, we have to tidy up the numerator. Numerator is the difference of two fractions. One easy thing to do is just to put everything under a common denominator. Notice that I kept the x plus h grouped, like I kept the x and the h in x plus h grouped together for reasons we'll see why. Oh well, minus x plus 3 times 5 x plus h, oops, plus 2 over 5 x plus h plus 2 times 5x plus 2. All of that divided by h. Of course, I won't forget the limit. Very important. As h goes to 0. Now notice here that I can rewrite this in the denominator. I can bring this thing down, right? Because, you know, a over b, or let's write this, a over b divided by c is just a over b times 1 over c, which is just a over bc. So really what I can do here is just bring the denominator of the fraction on the numerator down, and that's what I get. Now what I will do is expand the, the numerator of the numerator, basically. Okay, so what I will do now is expand it, but I will treat the x plus h as one term for reasons that will be clear. Of course, this will make things way easier. So I have 5x times x plus h plus 2 times x plus h plus 15x plus 6. Okay, this is done. Now, let me expand this part. It's 5x plus h times x plus 2x plus 15x plus h plus 6. Immediately notice that the x plus h times 5 will cancel out with the x plus h times 5, and the 6 will cancel out with the 6. So I mean, maybe I can write this clearly. These two, it's very clear that they will cancel out, and because you have a minus here, and that the 6 will cancel out with that 6. Okay, so I will write my expression without these. I mean, this is very clear. So what I'm left with is 2x plus h plus 15x minus 2x minus 15x plus h over 5x plus h plus 2 times 5x plus 2 times h. Okay, now this is very clear, right? It's the limit as h goes to 0. 2x plus 2h, what do we get? We get 2x plus 2h minus 2x, right? Plus 15x minus 15x minus 15h. I just distributed the minus over that thing here. I should really learn how to copy paste it efficiently. But yeah, okay. Maybe next time. Over h. And then what do you get? Boom, boom, boom. 2x goes away. 15x goes away. And then 2h minus 15h is minus 13h over 5x plus h plus 2. 5x plus 2h. Of course, I will do it quickly here because you know what the limit rules are. I'll cancel the h out and then evaluate the limit and by just plugging in, right, h is equal to 0, and we get it's minus 13 over 5x plus 2 squared. Of course, so f is differentiable, which is x plus 3 over 5x plus 2 is differentiable. For all x different than minus 2 over 5, and f prime of x is equal to minus 13 over 5x plus 2 squared for x different than minus 2 over 5. Okay, now that's one of the harder examples, but I mean, it's good to know how to do these cases. I mean, in class we have done some of them, and now we have seen another one. Of course, I've sent you, or I've assigned many examples of this form. Okay, now let us move on to this question. F of x is 1 over square root of 2 plus 3x. Now the domain of f here, what is that? It's just the x such that I need the number inside the square root to be positive, and I need it to be non-negative, and I need it to be non-zero. So really, I'm looking for 2 plus 3x to be strictly positive. So really, x is bigger than minus 2 over 3. This is the domain of f. Awesome. Now let us find the derivative. It's the limit as h goes to 0 of f of x plus h minus f of x over h. What is that equal to? Well, let's make this bigger a bit. Awesome. This is 1 over square root of 2 plus 3 x plus h, root 2 plus 3x. I mean, really, these are the same limit that we have done at the beginning, right? These have the form 0 over 0, right? These are indeterminate forms, and we're just looking to take them out, technically. Great. So what do I have here? I have a difference of two fractions on top. Well, what do I have to do? I just have to find the common denominator. Over. Okay, let me yellow the square root of 2 over h. There we go. Now, what I will do now is just put everything in one fraction. 2 plus 3x minus square root of 2 plus 3 times x plus h over that, right? These are the things we have seen a lot. And now I have a form that is 0 over 0. Of course, the source of the 0 over 0 is the numerator, right? And the h, the denominator, the first part of the denominator is nice, so I don't have to touch it. Great, so what do we do here? Really, it's the same old trick of multiplying by the conjugate, the top and the bottom. So let me do this. Well, I'll keep an h here. And let me multiply by the conjugate. I'll change color a bit. Well, let's see, let's put it in blue. That's fine. This is just root 2 plus 3x plus root 2 x plus h, and the bottom as well. Boom. We got this. At least I hope. Okay, great. Of course, we'll keep this. So really, the top, does the top become? It becomes 2 plus 3x minus 2 plus 3x plus h, right? Over that thing here. Okay, really, I wish I was able to copy paste it. I think I'm able. I think I just have to figure out how. Times h times the square root of 2 plus 3x plus the square root of 2. Okay, it's getting longer than I had anticipated, but that's fine. Great. Now, oh god. Okay, this is the limit as h goes to 0. Let us look at the top. The 2 will cancel out. 2 minus 2. And then 3x will cancel out with 3x. So what we are left with is just minus 3h. Right? Just expand that thing. And you'll get minus 3h. This is 2 square root of 2 plus 3x. Square root of 2 plus 3x. X plus h. Of course, I have an h that I will be adding. H here. And that h will go away. Right? I can cancel it out. And then evaluate. And then compute the limit just by evaluating at 0. H equals 0. So what do we get? We get minus 3 root of 2 plus 3x times root of 2 plus 3x times what? Times 2. Right? This is, well, let's write it down here. Times root 2 plus 3x plus root 2 plus 3x. What do we get here? Well, so I have here 2 square root of 2 plus 3x times 2 plus 3x. So what do we get? We get 3 over 2 plus 3x to the 3 halves. Okay, and in order to check this, it's a good idea to look at the chain rule, right? You need the chain rule to verify this result, which we have seen in class today. So you could do that using the chain rule and verify that this is the good answer. So let's see, it's, right? F of x is 2 plus 3x to the minus 1/2, right? So you get, yeah, okay. Awesome. So if f of x to the minus 1/2, then f is differentiable. I mean, here I need 2 plus 3x to also be strictly bigger than 0, right? Because it can be 0 and it needs to be non-negative. So for x bigger than minus 2 over 3, and f prime of x, what's happening here? And f prime of x is equal to minus 3/2. And just bring the exponent down if you wish, or you could keep it the same way. 2 plus 3x to the 3/2. Okay, great. Now we move on to an easier question to find the derivative of this function. Now f is defined, the domain of f. The domain is always a set, but anyways, I did not write it this way. But the domain of f is defined for x squared different than 1, right? So x is different than 1, and x is different than minus 1. So the domain of f is minus infinity minus 1, union minus 1, 1, union 1, plus infinity. Now here let us find f prime of x using the definition. F of x plus h minus f of x over h. Great, of course, here x is different than 1 and different than minus 1. Let me get this bigger. Very good. As it goes to 0, let's see. These are very good examples, I feel, because they englobe like many cases. Of course, still can have lots of other cases, but these are good ones. I suggest that you do them all on your own and look at the solution to every question that you don't know. Of course, you should try and struggle with it first. Anyways, so it's the same idea. I will put everything under a common denominator, and really just in the same way that we have done previously, I will just allow myself to write this immediately. Okay, just writing it's x squared minus 1 times h. Now here, this is very clear. It's a 0 over 0, right? So the minus 1 minus minus 1, so that becomes minus 1 plus 1, so the minus 1 will go away. So we just get x squared minus x plus h squared. Well, let's do it here, minus 1 plus 1. We won't lose anything. X plus h squared minus 1 over h. Let's hope for the best. What do we get here? X squared minus x plus h squared. So x squared, let's try to do it mentally. X plus h squared is x squared plus 2hx plus h squared, right? X plus h squared. Now, so when you write this, what you're left with is minus 2hx minus h squared. So really, you have minus 2hx minus h squared over x plus h squared minus 1. Yep, it's a lot of writing, but that's fine. It's very important that you get used to it. Awesome. I usually don't write here, but let me do this here. It's the limit as h goes to 0, factor an h out, minus 2x minus h over x plus h squared minus 1 over x squared minus 1 times h. Of course, you can cancel the h out here and evaluate the limit by simply plugging in h is equal to 0. So what do you get? You get minus 2x over, this becomes x squared minus 1 times x squared minus 1. So you have an x squared minus 1 squared. Of course, f is differentiable for any x different than 1 and x different than minus 1, and f prime of x is equal to minus 2x over x squared minus 1 squared. That we can check by the quotient rule or by the reciprocal rule. The derivative of 1 over something is minus the derivative of that something over that something squared, which we can see that we got the right derivative here. Okay, awesome. Enough with the limit definition. Oh no, we have one more. Let's see. Well, this one is easier. Find f prime of 2 if f of x is square root of 1 plus 2x squared. Here, I think I plan to do this with the other definition of the limit. I plan to do this with f of x minus f of 2 over x minus 2. Now, what is f of 2 here? F of 2 is root of 1 plus 2 times 4, which is root 9, which is 3. So it's the limit as x goes to 2 of square root of 1 plus 2x squared minus 3 over x minus 2. Of course, this is 0 over 0. You know, and you have seen many examples of such limits. So this should be easy. What do? I multiply by the conjugate. Okay, let's see where this goes. On top and on the bottom. Okay, let us expand the top. The bottom, really, the only thing that's giving me 0 is the x minus 2. This thing is giving me root 9 plus 3, 6, so I'd better not touch it. So let us factor on top. So what do we get? We get 2x squared, 1 plus 2x squared minus 9 over x minus 2 times the square root of 1 plus 2x squared plus 3. So this is the limit as x goes to 2 of 2. Let me do it quickly. So this is 2x squared minus 8, right? And then factor it out, you get it's 2 times x squared minus 4. So this is just this. X minus 2, x plus 2 times 2. And you have an x minus 2 here. This is the square root of 1 plus 2x squared plus 3. You can cancel out the x minus 2's and then simply evaluate the limit by plugging in 2. So what do you get? You get 2 times 2 plus 2 over square root of 9 plus 3. So you get 2 times 4 over 6. So what is that? This is just 4 over 3. Okay, so f prime of 2. So f is differentiable at 2. And f prime of 2 is equal to 4 over 3. Okay, this is using the definition. Of course, we know how to do this now with the chain rule, but this was meant to be done with the definition. Okay, great. Now, let f of x is equal x cosine 1 over x if x is non-zero, and 0 if x is equal to 0. Is f differentiable at 0? This is easy. So let us look at the limit as x goes to 0 of f of x minus f of 0 over x minus 0. If this limit exists, then f is differentiable at 0. If it doesn't, then f is not, right? Very easy. F of 0 is 0. And if x is going to 0, this means that f of x is non-zero. So f of x is x cosine 1 over x. F of 0 is 0 divided by x. So this is the limit as x goes to 0 of cosine 1 over x, which does not exist, dne. So f is not differentiable at 0. Okay, this is a limit that you have seen many times. So, I'll allow you to review your notes in case in case you have forgotten about this. Okay, so this function is not differentiable at 0, but I'll leave you to check that f is continuous at 0. So a good question would be, is f continuous at 0? And the answer would be yes. Yeah. Okay, use the squeeze theorem. You can prove that. Anyways, let us move to the last question. Is to find a and b so that the function f given by x squared if x is less or equal than 4 is less than or equal to 4 by x squared, or is equal to ax plus b if x is strictly greater than 4 is differentiable at 4. Okay, so really, before we begin, notice that we have two unknowns. So what we need is two equations, right? We need two equations to solve for two unknowns, technically. Okay, great. So, first of all, notice that if f is differentiable at 4, then f must be continuous at 4. What does that mean? This means that f of 4 should be equal to the limit as x goes to 4 minus of f of x, which is equal to the limit as x, which should be equal to the limit as x goes to 4 plus of f of x. Now f of 4, notice that since f of x is x squared, if x is less than or equal to 4, is 16. Now if x is strictly less than 4, f of x is still x squared. And if x is strictly bigger than 4, then f of x is ax plus b. So what do we have here? We have that 16 should be equal to 16 and should be equal to 4a plus b. So this is one equation. One equation comes from the continuity of f. Great. Now we need that the limit as x goes to 4 of f of x minus f of 4 over x minus 4 exists. So we need that the limit as x goes to 4 plus of f of x minus f4, f of 4 over x minus 4 is equal to the limit as x goes to 4 minus of f of x minus f of 4 over x minus 4. Now notice that f of 4 is equal to 16. So if x goes to 4 plus, f of x is what? Is ax plus b. F of 4, so notice that f of 4 is 16, is 4a plus b. So it's better here to replace 16 by 4a plus b, just because I have a lot of unknowns. This is 16, right? 16 is 4a plus b. So f of 4 is equal to 16, which is also equal to 4a plus b over x minus 4. x4 minus, so this is x squared. Here it's better to keep it as 16, right? Over x minus 4. Of course, I can use those two interchangeably. 4a plus b is equal to 16. So let's see now. What do we get? We get ax minus 4a over x minus 4 is equal to the limit as x goes to 4 minus x squared minus 16 over x minus 4. Factor out the x squared minus 16 to x minus 4 times x plus 4. So what we're left with is x plus 4. And here what we're left with, just factor na, or factor na out. So what do you get here? You get a times x minus 4. So you get a is equal to 8. Right? Write this as a times x minus 4 over x minus 4. Well, let me factor this out. That's fine. X minus 4 over x plus 4 over x minus 4. This is the limit as x goes to 4 minus of x plus 4. So here you get a, and on the other side you get 8. So a is equal to 8. B, what is b equal to? We had the relation that 16 is equal to 4a plus b. So b will be equal to 16 minus 4a. So it's 16 minus 32. So it's minus 16. So a is equal to 8. B is equal to minus 16. And these are the values of a and b that will make f differentiable at 4. Okay, thank you everybody, and I hope it was helpful. And sorry for taking so long. I did not expect that. Thanks.